Hi guys, Miss Keen. Alright, we're starting investigation 4, which is on page 65 if you'd like to follow along in your book. So as you can see, the title says Applying Congruence in Symmetry. Okay, and we have been talking about symmetry with congruent shapes when we talked previously about transformations, about rotations, reflections, and translations. But there are some theorems or rules that apply every time these situations come up. You have congruent shapes. All right, so let's talk. I've said this word congruent, so let's make sure we understand what the word congruent means. So the word congruent, right here, it means same size and same shape of two polygons, geometric figures. So we have some examples of this. So let's see here. We're going to make sure these two triangles are congruent. And there are different rules that we can make sure that they're congruent. One of our first rules is this. It's called side, angle, side. And we like to abbreviate it as SAS. Okay? We like abbreviations in math. Now, side, angle, side. You can see the definition on your page here. It says two sides in the included angle of one triangle are congruent to two sides in the included angle of another. What does that mean? Okay, so let's look at our figure down here. First of all, let me talk about these symbols right here. This right here is called a hash mark. Okay, and a hash mark means that you have a side length that is equal to a side length on another figure. And you can see that same hash mark is over here on the other triangle. Now, down here you have two hash marks. Same thing. And this side length is congruent to the side length on the other figure that also has two hash marks. So hash marks are meant for side lengths. The other symbol in this figure is right here, and it's referring to the angle, and this is called an arc. Okay. When you want to indicate that you have equal or congruent angle lengths, you use this symbol called an arc, and you can see we have an arc on, I'm going to call this triangle 1 and triangle 2. So in triangle 1, we have a hash mark on the side length, we have an arc on the angle, and then we have two hash marks on the other side length. Now in triangle 2, we have one hash mark, an arc, and then get two hash marks. Again, switch colors. Now, what tells me that these two shapes are congruent is this rule. Side, angle, side. Okay? It's important that it goes in this order. It's important that the angle is in between both of the side lengths. That's why it says included angle. It's the angle that's in between the two side lengths. So here we have a side, and here we have an angle, and here we have another side. As you can see, that angle is attached to both of those sides. It's not an angle out here that's only attached to this side and not this one. It's not this angle that's attached to this side down here, but not this one. It's the angle in the triangle that's attached to both of the sides that we're talking about. So does that match the pattern in the other triangle? Let's take a look. So we come over here and we have side. I'm just going to use our abbreviations, S. We have an angle, for A, and we have the other side. So because we have the same pattern in both of the triangles, we can definitely say that these two triangles are congruent, and we say that they're congruent because of this rule, SAS. Okay, that's rule number one. There's a total of 3. Go ahead and pause if you need to write this down. And I'm going to continue to the second rule. Okay, the second rule is this. Rule 2, ASA, otherwise known as angle, side, angle. Okay, and you can see the definition here. It says two angles in the common side in one triangle are congruent to two angles in the common side of another. Again, we have important words here. Common side. Okay? Just like rule number 1, SAS, this rule is also important in the order that you have indicated on each of your triangles. Okay, so first I'm going to look at we'll call this triangle 1 and triangle 2. I'm going to look at triangle 1, and I have some symbols here, right? What's this symbol called right here? What's that called? It's called an arc. Okay, and what's this symbol called down here? It's called a hash mark. Okay, so I have equal symbols on triangle 2 that I'm going to look at. All right, so in this one, instead of having two sides indicated, I have two angles that are indicated to be congruent to two angles on the other triangle. So let's take a look. I have an angle, which I'm going to call A for angle. I have a side, and I have an angle. Now I need to look at triangle 2 to make sure that same pattern applies. Okay, I have angle, I have a side, and I have an angle. Because I have the same pattern and because I have two angles in a common side that are congruent, both of these shapes are completely congruent to each other. Now let's talk about that common side. As you notice, you have the angle and the angle. Common side is this. If I was to draw a line, that's not very straight. If I was to draw a line segment along the bottom of that triangle, it would touch both of these angles. So this side is in common with both of those angles. Same thing applies over here. I have a side that's in common with both of those angles. Because this rule is satisfied, both of these shapes are congruent by this rule, ASA. That's our second rule. Now our third rule. Remember, you can pause anytime if you need to write this down or I'm going too fast for you. Here we go. Third rule is this. Two triangles are congruent if any of the following are true. Okay, our third rule is called side, side, side. SSS. Okay, by this point you can probably guess what side, side, side refers to. And here's the definition. Three sides of one triangle are congruent to three sides of another. Okay, you can see it's indicated because we use on our sides, on our side lengths, we use hash marks. We have one hash mark, two hash marks, and three hash marks. Similarly, on the other triangle, we have one hash mark, two hash marks, and three hash marks. Now, on these triangles, the one hash mark, what that says is this side length of this triangle is equal or congruent to the other triangle where there's just one hash mark as well. So these two are congruent. The one with 2 hash marks, this side length is congruent to the side length that also has 2 hash marks. And likewise on the bottom, 3 hash marks, so this side length is equal to this side length with 3 hash marks as well. All right, so let's take a look. Let's look at our pattern. We have a side, we have a side, and we have a side. Okay, over here we have a side, we have a side, and we have a side. So both of these triangles are congruent by this rule, side, 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 or S, S, S. Those are the 3 rules that we are going to be using to determine if triangles are congruent to each other. If one of these rules does not apply, we cannot say that the 2 shapes are congruent. Sometimes we look at triangles and we think they're 90-degree angles. They could be very close. Our eyes fool us. You cannot tell the difference between an 89-degree triangle and a 91-degree triangle. Unless it says it's a 90-degree triangle, you cannot assume that it is. And unless you know by one of these 3 rules, ASA, SAS, and SSS, unless you know by one of those rules that 2 shapes are congruent, you cannot assume that they are congruent. So let's take a look at some examples. Okay, so are these 2 triangles congruent? If so, what is the congruency rule that applies? All right, so using the 3 rules that we just learned, SAS, ASA, or SSS, which of those 3 rules says that these are or may be congruent? Go ahead, choose one. All right, if you chose SSS, you would be correct. Side, side, side. And that matches the pattern side, side, side. So these 2 shapes are exactly congruent. They're exactly the same size, same shape, according to our congruency rule of SSS. All right, let's try the next one. All right, how about these? Are these 2 congruent? If so, pick your rule, SAS, ASA, or SSS. All right, let's take a look. If you said that these were congruent by rule ASA, you would be correct. A for angle. I'm sorry, I made a mistake. Whoops. That's not ASA. I got carried away. It's SAS. Sorry. This is side, this is an angle, and this is a side. Okay, likewise, side, angle, side. Now remember the important rule of using SAS to determine congruency is that the angle, the congruent angle right here, has to be between both of the sides. It has to be the included angle. If it's not the included angle that's congruent, you cannot use this rule. All right, let's try the next one. All right, so you're going to ask yourself, are these 2 congruent? If so, which of the rules applies? Go ahead. All right, so let's take a look at this. We have an angle that's congruent to this angle over here. And we have this angle that's congruent to this angle over here. And then we have our third angle that's congruent to this angle over here. So there is no angle, angle, angle rule, so we cannot say that these are congruent. They may be congruent, but they may not be congruent. We do not know. We do not have enough information. And let me just show you a little example of this. So say these were, let me get 60-degree angles, equilateral triangle, right? If I take this shape and I shrink it, so it's that size. So you can clearly see that they are not congruent with your eye. I've made it that way so you can tell. Did it change the angle length, angle measurements? No, there's still 60-degree angles. When you change the shape, the size, I'm sorry, when you change the size of the triangle, it changes the length of the side lengths, but it does not change the measurement of the angles. So there is no angle, angle, angle rule because in this example, I have not changed any of the angles, but you can definitely see that they're not congruent. Okay, so if you have a combination that's angle, 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 that is not necessarily congruent. You cannot say that these two triangles are definitely congruent. All right, let's try our last one. All right, so same question. Two triangles, are they congruent? And which rule? Okay, so let's take a look. All right, we have an angle, we have a side, and we have an angle. Okay, we have an angle, a side, an angle, and an angle. So let's compare the two. In triangle 1, we have two angles in one side. In triangle 2, we have two angles in one side. So are these two congruent? They're not congruent. Remember the definition of ASA, I'm not going to write it down because they're not congruent. The definition of ASA is that that side has to be in common with both of the angles. So on triangle 1 it is in common, but if you look over here on triangle 2, the side is not in common with both of the angles. So this one is not congruent. All right, so those are some examples in the three different types of triangle congruency rules. So, all right, play it again if you need to. Talk to you later.